Okay, so in front of us is a faulty Titan XP. Unlike most of the broken cards we get, we're not going to start with a voltage and resistance check, because instead, I've gone ahead and just put it under load. If we go ahead and look at the screen, you'll notice this thing has been under load for about 2 hours and 40 minutes now. The reason why I do this is to illustrate that this card is a bit weird, in that unlike most of the broken cards we get, so that let's say crash, this does not crash under load. No. Instead, this card has the unique disposition of crashing on idle. So like I mentioned, the card has been running under load for 2 hours and 40 minutes, and it's done so without issue. However, if we go ahead and turn off or close the GPU-Z render test, in a short while, this card should crash, in particular when the voltage at the GPU drops to 0.65, and there we go. Okay, the card has crashed, and if we look at the card itself, you might be able to hear that the fans are running at max speed. So let's go ahead and take the card apart and try to determine what's gone wrong. Okay, as you can see, the card is disassembled. If you're wondering why it looks the way it does, it's because it's an XLN2 overclocking card, and also because it's undergone quite a few customer repair attempts. For a card like this that crashes at idle but not under load, you want to be paying attention to two particular inductors and the V-core phases connected to those two inductors. So, in particular, you want to be paying attention to the two phases connected to this inductor and the two phases connected to this inductor. What makes these particular inductors special is the fact that they actually have 4 MOSFETs connected to them each, instead of the regular 2 found at this, and this inductor. Since these two inductors are our main suspects, we want to first confirm at least one set of MOSFETs on each inductor is turning on when we first boot the card. So to do this, we want to measure the switching frequency found at the first inductor pad here and here. So with my multimeter in switching frequency mode, if you will. We're going to start by checking the bottom inductor. We should see about 300 or so kilohertz, and this one, I suspect this is the one that works, and as you can see, we have 320 kilohertz. Okay, that's perfectly good. And now if we check the topmost inductor, you'll notice that we have 0 hertz, which tells us that neither set of MOSFETs here or here are turning on, and by extension we have a, in a sense, non-working V-core phase. Okay, so since we don't have a single working phase connected to this inductor, our primary suspect at the moment are the gate drivers themselves. So for these two gate drivers, we want to be checking their enable signals, and in particular whether they get an enable signal. So the enable signals for both gate drivers can be found on the back of the card over here for the bottom gate driver and over here for the top gate driver. Like all the AND gates that we get, we have to diagnose. We want to be checking if there's an output, and if it's missing its output, we want to be checking if it has VCC, input 1 and input 2, and we want to do this for both AND gates responsible for generating enable for this gate driver and this gate driver. So we're going to start with the AND gate that generates enable for this driver and then move on to this one. So anyways, first let's check the output. 0 volts. Okay, now let's check VCC. 3.3, perfectly good. Now let's check input 1. 3 volts, which is high enough. Now let's check input 2. 0 volts, which is of course going to be a problem later on that we have to fix. Now let's check the AND gate for this gate driver over here. So first let's check the output. 0 volts. Now let's check VCC. 3.3, perfectly good. Now let's check input 1. 3 volts again. Now let's check input 2. 400 millivolts, or 390 I should say, which is not high enough. Okay. We're missing input 2 for the AND gate that generates enable for this gate driver, as well as the other AND gate that generates enable for this gate driver. So, because we're missing input 2, we have two main possibilities. The first is that the input is not being generated, or I should say not being generated fully, to 3.3 volts or whatever it's supposed to be. And the second is that it's being shorted, but it is generated. So, what we're going to do is we're going to check input 2 on both gates in resistance mode to see if it's shorted, and if it's not shorted, we're going to turn it on and see if it gets shorted while the card is on. So checking the AND gate for the bottom gate driver, 2.8 ohms, which is far too low. Now checking the other AND gates, 16 ohms, again, far too low. So as you can see, we have a short, and by extension, a dead component. So even without a thermal camera, I can more or less tell you which component this is going to be, and I know this because this particular issue is more or less unique to the reference GP102 PCB. And the reason why it's more or less unique is because of the way the V-core phases connected to this inductor and this inductor are wired. So basically, when you use the card, the PCB doesn't use all the phases connected to this inductor or this inductor at idle or even under load. The PCB has to be able to switch between, let's say, using the bottom phase for the topmost inductor or using the topmost phase. And basically, what's happening in this case is that the component that's responsible for switching which phase is in use isn't able to even select any phase, and that's why we don't have a switching frequency on this inductor. So which component is responsible for selecting which phase is in operation? Well, it's this thing over here. So anyways, given that this is our faulty component, let's go ahead and replace it and see if the card becomes any more functional. So anyways, like I mentioned earlier, I'm dead certain this is the source of our shorts, even though I haven't confirmed it with the thermal camera. And before we go ahead and replace it, let's just confirm the short on input 2 here. Yep, as well as input 2 here. Okay. Okay, let's see if we still have a short on the input 2 of our AND gates. So checking the one on the right for the bottommost gates, we're good. And checking this one over here, we're good, but ground still gives us a beep. Yep, so yep, our short is gone, so let's go ahead and put the card back on the bench and see if we get a switching frequency on the topmost inductor. If we now go ahead and power the card on and check for a switching frequency at the first inductor, you'll notice that we have 320 kilohertz, which tells us that at least one of the two V-core phases is now turned on, and by extension the card should be fixed. So let's go ahead and put the cooler on and run it at idle for an extended period of time. Okay, anyways, as you can see, the card's put back together, and if we look at the screen, you'll notice that the card has been idling for about 5.5 hours as I was, away. Anyways, the card can now definitely idle, so let's now just stress test it and end the video. Okay, as you can see, the card now works. So the basic gist of it is that on these reference GP102 PCBs, at the topmost inductor and one of the middle ones, there is as you saw, two phases connected to each inductor, and that there is also a component responsible for selecting which phase is in operation at any given moment. I should note that both phases don't turn on at the same time, it's always one or the other. And for this card, the fault was that that component that selects which phase is in operation wasn't selecting any because it was shorted, and replacing the component was enough to get the card working. I should note that in my experience, it's typically the topmost phase that has problems, not the middle phase, as typically components get knocked off towards the top and edges of the PCB. Anyways, if my video on my channel should help you out, consider subscribing to me on YouTube, or telling a friend about me, or submitting repair requests. I take other devices. You know, if you have something that's not a graphics card, I would love to look at it. I have laptop and metal detector remote repair videos. I'd love to expand my collection to basically anything, really. But anyways, you can submit a repair request on my website, www.techcemetery.com. In either case, though, I hope you learned something watching this video, and hopefully I will see you in the next one.